In the diagram, ABCD is a cyclic quadrilateral such that AC is perpendicular to CB. So AC is perpendicular to CB, we see that 90-degree there. And DC is equals to CB, indicated by these lines here. AD is produced to M such that AM is parallel to MC. Let B equal X. 10.1.1, prove that MC is a tangent to the circle at C. So we need to prove that this is a tangent and we have this to work with. So for now, let's just focus on trying to express as much as we can, express as much information as we can within this diagram. So just expanding on what we're given. If this is X and this is a cyclic quadrilateral, then that would make A2 90 minus X. And since CB subtends A2, DC also subtends 90 minus X. The reason being they are equal chords here. So DC is equal to CB. That makes those two equal. What else could we say? We know D1 would be 180 minus X. Since these are opposite sides of a cyclic quadrilateral, and that would mean that D2 is equal to X, like that, because we know that these are supposed to add up to 180. Therefore, that would mean C2 is equals to 90 minus X. So do you see, just flowing with the information that you're given, you're able to arrive to the answer, even if that's something that you're not particularly looking for at the moment. But there you go, there's your 90 minus X. But now you need to write it in terms of actual steps. And this is not the only way that you can arrive to this answer, but that is the primary way in which we are to solve this problem, by first of all asserting that A1 is equals to A2. So firstly, let's say A2 is equals to 90 minus X. How do we know this? This is interior angles of a triangle, in this case triangle ACB. Then we can say A1 is equals to A2, which is equals to 90 minus X. This is equal chords subtend equal angles. So equal chords subtend equal angles. Then from this point, we said that, well, in this case, it's not even necessary. Let's see. Okay, it is. A1 is equals to 90 minus X. That's what we get from that statement. Then we can say separately that D is equal to 180 minus X. This is opposite angles of cyclic quad. Then we can then say D2, this was D1, would be equal to X, because this is angles on a straight line. Then we can say C2 is equals to 90 minus X. The reason now being interior angles of triangle, and in this case triangle DMC. Then we can then say C2 is equals to A1, or rather from here we can conclude that MC is a tangent. The reason being tan chord, or the converse of tan chord theorem stands. Converse. It's not necessary to add the converse, but that is your reason.